Hey, so this is Chrissy Henderson, and I'm going to be pretty much comparing t-tests and ANOVAs in this, and how I'm using them to compare my data. So I just wanted to kind of start off by going over my project and kind of where the data I'm using is actually coming from. So my project is working with oak savanna restoration, and I'm mostly looking for bird nests, and we've also collected some vegetation data for those nests and then stand-wide averages. And so why we're doing this, there's basically a decline in avian abundances, and so specifically disturbance-dependent bird species. And so we think the fix to that is creating oak savannas, so you have the more open understory area and grassy area, and then you have those trees in the canopy that are going to create that overstory for some of the later successional birds to be able to nest in. And so the 4 study species I have that I'm going to be using are prairie warbler, field sparrow, red-headed woodpecker, and I'll be using ovenbird today, but we switched it out with red-eyed vireo. And so it kind of is, covering the 4 different nesting strata by using these species. So the field sparrow is more nesting on the ground. The prairie warbler is going to be nesting a little higher up, 5 to 15 feet up. The red-headed woodpecker is a cavity nester, and then we have the ovenbird, which will be nests on the ground. So as far as treatments go, all the data I'm going to be using today is coming from Catoosa Wildlife Management Area, which is out in Crossville, Tennessee. And we also have a couple other study areas, but I won't be using those today. And we also have 5 different treatments. So we have controls. This map is actually of Catoosa. We have controls and then a mix of burns and cuts. So we have a dormant or growing season burn and then a low or high residual basal area. So for example, you can see on the map, it's like a dorm low, dorm high, grow high, and we have 2 reps of each of those. Okay, so I'll show you the data I'm actually going to be using so you can kind of get an idea of what I'm looking at. So here are those 4 species that I was talking about earlier. And then I have what stand they correspond to. Height is in centimeters. We have live basal areas in meters squared per hectare. Dead basal area, meters squared per hectare. Canopy cover in percentage, herbaceous height centimeters, woody height in centimeters. Herbaceous ground cover is in percentage, and then we have sapling density, which is saplings per hectare. Alright. So I started off what I'm doing. I can just start off, pretty much by bringing in my data, and I'm going to read it in as data, and I just, pull up the names just to get an idea to make sure it came in okay. And what I'm going to be showing you guys is how to subset your data. This is not what I used initially. I'm kind of doing this for the webinar because when I did mine, for example, I pulled out, I'm doing just the prairie warblers for this one because with t-tests you can really only just compare 2 means. So I just wanted to compare it for this specific species, and I could do it for the other species, but I'm just doing this as an example. So for live basal area, I had all of the live basal area for the prairie warblers, and so this will just subset the prairie warblers specifically, so you can see there's all the prairie warblers, and that's just saying to pull it out of data, and then all the species that equal PRA we need to pull out. And so to create this right here, I went ahead and just did this by hand because it is such a small data set. I actually created this code for the webinar specifically, but it works really well. You wouldn't want to do it by hand, obviously, if you're going to be doing a huge data set. So for this, I just used a string of if-else statements, and so under prairie warbler stand, if the stand equaled control, I wanted it to equal this number, which is the live basal area that was averaged in that stand, which I got from Andy Vanderyacht's data. He collected a bunch of vegetation data, so I'm just using it as the stand-wide averages. So for this, I'm comparing the means. So I had talked about doing nest success earlier, but I'm trying, for this study specifically, what I'm doing here is looking at nest site selection. So I'm comparing So for specifically live basal area, if I'm looking at, oh, okay, so prairie warblers nest specifically in areas with higher live basal area than compared with the stand, then maybe have a better idea of where to search for nests, for example. So this is the stand-wide average for control. This was a stand-wide average. I'm going to explain, these are actually different, we use different naming systems. So the spring is that's the dormant season, fall would be the growing season, and then we have a savanna, which is the low basal area, and woodland cut, which is the high basal area. So we kind of renamed those. And then this is, continuing on basically from what I explained with the control. And the last one, you don't have to do an actual equals statement right there. It's just going to essentially add that in wherever you didn't have a number that was explained by these other lines before. And this whole statement is just going to create a line of numbers that you can basically column bind to your original numbers, and then you can export that and use that as a data set. So I'll go ahead and run that. And then as you can see, I'm actually just going to go ahead and show you guys what came out. So it's all the string of numbers, and it just pulls out. So this would be the first prairie warbler and the second and the third, and that actually works out pretty well. So now I'm going to column bind what I just did to that prairie warbler live basal area before, and you're going to have to do it as a data frame, because when I did it just as a column bind, it gives you a matrix, which you can't do a t-test with. So I'll go ahead and do that. And then I actually wanted to look at the string to see to see if it was a factor or numerical. So I went ahead and displayed those, and you can see they're factors, and you can't do a t-test with factors, so I went ahead and changed them to numerics. And this is something I found on the internet kind of searching around. If you see that as numeric is not working for you, you can go ahead and change it to add in this as character, and it will help switch it over to the actual numeric. I don't know what it was doing before, it was just being really goofy, so this is something that is definitely going to fix that problem. And so I'm putting in the V1 was actually, as you can see down here, that's what the original, that PRA LBA is showing up as. So I'm going to go ahead and say that and change those both to numerics. And then I'm going to run it again. As you can see, they're both numerics down here, so that works out really well. So as far as a t-test, we're going to want a paired t-test for this one, because I connected those the birds, these with the correlating stand, so they are related. So I'm going to go ahead and run that as a paired t-test. And as you can see, the live basal area they're definitely picking something different than what's in the stand. So to be able to look at that, to see is it, higher or lower, we can go ahead and look at the means, and as you can see, they're picking areas that are lower in live basal area. So now I'm going to go over what I did, which is going to look a lot easier when I actually display it on here. So I'll start with the live basal area. I went ahead and, like I said, I did that by hand, this part, which was pretty straightforward and didn't take me a whole lot of time. And I actually just, I had those as CSVs that I went ahead and I'm just going to pull those in right now. And I ended up choosing these 4 variables because Andy actually is about to have a paper published that he's showing basically that those 4 variables are affecting the species composition of these oak restoration savanna stands. So I went ahead and wanted to see if maybe those were affecting the nest site selection, for example. So I'm going to this is what I did up there running the t-test. So I've got the same answer. So it definitely worked up there, which is really good to see. Running the means again, same thing. So now dead basal area, I'm going to run through that. And as you can see, it is not significant, and those numbers are both pretty close to each other, which makes sense for not being significant. I'm going to run it for herbaceous ground cover. So hugely significant with a paired t-test. As you can see, they're picking areas that have way higher herbaceous ground cover, which kind of makes sense if you're having less live basal area. Perhaps, you know, more light is getting down to the ground and creating that higher amount of herbaceous ground cover. As far as sapling density goes, also very different numbers, very different means. I'm going to look at the means there. As you can see, they're picking nest sites that have a huge amount of sapling density going on, which makes sense. I mean, if you're a nesting bird trying to hide from predators, you want to pick areas that are probably better concealed. Okay, so for this second part, I'm going to go over ANOVAs and pairwise t-tests. So I couldn't really use the data I just used for these ANOVAs because you need more than 2 means to run an ANOVA, and you can only really use 2 means for a t-test. So I kind of went with a different data set. I went with this whole data set that I showed you at the beginning. So I'm going to be comparing the nest site selection between all 4 species. And in theory, they all should be, you know, it's kind of different because they all have different nesting strategies. It'll be interesting to see what is different for those. I'm going to use those same 4 variables that I just used. So I'm just going to read that data in just again to be sure. All right, so this is kind of a run through I wanted to show you guys. So the height, it's definitely going to be different. I already know that because the ovenbird's a ground nester, prairie warbler, like I said, is like 5 to 15 feet. The field sparrow is kind of like 5 feet, and then the red-headed woodpecker is like 30 to 50 feet up in a cavity, so it's going to be way on up there. So they're definitely going to be different. So I'm going to go ahead and run that, and that's basically telling it to look for height. So to run an ANOVA of height by species using the data, which is the one that I pulled in right here. And then I'm going to get a summary of that ANOVA, and it's going to show me that at least one of the means is different based on that value. So to find out which one is different, I'm going to have to do a pairwise t-test, so it'll compare all those means and give me a nice pretty graph to look at, or table. And I ended up running with this p-adjustment method, the Bonferroni one, because of what Dr. Zobold said in class about that one. It kind of, you end up dividing by the number of comparisons, and it kind of reduces your chances of getting a false positive, and that's something that I thought would be very helpful to this analysis. So it's basically, I'm going to do height by species and do a Bonferroni. So as you can see in this graph, the red-headed woodpecker is hugely different than the rest of those guys, which makes complete sense. And the prairie warbler is a little different than the field sparrow and the ovenbird. And the ovenbird and field sparrow are almost not even different at all. So this is a really interesting method. I really kind of enjoyed this for something that's pretty simple. And so this t-apply is going to be really nice because it'll give me all the means for height so that I have a really good idea. So you can kind of compare just by looking at that, you know, oh, red-headed woodpecker is clearly higher. And so this is kind of maybe a little backwards than what I thought, just as a tip. So like, I thought it would be species and then I want it by height, but you have to do it height and then I want it by species and then mean. So you could do anything you want there. You could have median or min or max. So for live basal area, I'm going to do the basically what I just did. I'm going to run that again for live basal area. So this is telling me definitely one is at least different. And so I'm going to run that pairwise t-test. And as you can see, field sparrow is very different than the ovenbird. Ovenbird is pretty much way different than the other 3 species, which makes sense with live basal area because you find those guys in forests, mature forests, versus the other 3, which are in a little bit more open habitat. So as far as dead basal area, actually not significant. So all the means are not really different from one another, and I'm just going to look at the pairwise t-test. You actually wouldn't, in theory, you wouldn't have to run this if they're not significantly different, but I'm going to go ahead and run it just to look at it, and you can see they're all pretty much the same except for red-headed woodpecker and ovenbird. Which makes sense. If a red-headed woodpecker really likes cavities, it might be, slightly different. So as far as herbaceous ground cover, so yeah, definitely one mean is different than the other. So I'm going to run that pairwise t-test. And it's looking like ovenbird is different than everybody again, which once again makes sense. If he's, if they're nesting in the forest, you don't have a lot of light getting to the ground, not a lot of herbaceous ground cover. And as you can see, ovenbird is a lot lower than these other guys. And this is in percentage too, so it's pretty different. So for my last one, sapling density, I'm going to run those guys. And almost significantly different. And pretty much red-headed woodpecker is different than the other guys, so which makes sense. Those areas are pretty dense where those guys are. There's a lot of light coming in. So yeah, that's pretty much the comparison of those two. You can't really use the same data set for those, like I said earlier, which kind of stinks in a way. I didn't know quite what else to use for something that would be for a t-test. That I've seen that cited actually used in nest site selection studies using a t-test. It's kind of a pretty basic test, but I mean, if it's simple and it works, like, I'm pretty much down with that. And it's nice to see, something that I can use the ANOVA for. A lot of my studies, the nest success is pretty much you do that in MARC through a Mayfield method, and that's a little bit too complicated for this class right now, so I'll end up doing that later. So thanks a lot, and I hope you enjoyed it.